but here I'm going to call it way, short for weights. But this is RA. And this is how much of every row we want to average up. And it's going to be an average because you can see that these rows sum to 1. So this is RA. And then RB in this example, of course, is X. So what's going to happen here now is that we are going to have an expo 2. And this expo 2 is going to be way multiplying Rx. So let's think this through. Way is T by T. And this is matrix multiplying in PyTorch a B by T by C. And it's giving us what shape. So PyTorch will come here and it will see that these shapes are not the same. So it will create a batch dimension here. And this is a batched matrix multiply. And so it will apply this matrix multiplication in all the batch elements in parallel and individually. And then for each batch element, there will be a T by T multiplying T by C exactly as we had below. So this will now create B by T by C, and expo 2 will now become identical to expo. So we can see that the torch.allClose of expo and expo 2 should be true. Now, so this kind of like convinces us that these are in fact the same. So xbow and xbow2, if I just print them, okay, we're not going to be able to, okay, we're not going to be able to just stare it down, but, well, let me try xbow basically just at the 0th element and xbow2 at the 0th element. So just the first batch, and we should see that this and that should be identical, which they are, right? So what happened here? The trick is we were able to use batched matrix multiply to do this aggregation, really. And it's a weighted aggregation, and the weights are specified in this t by t array. And we're basically doing weighted sums. And these weighted sums are according to the weights inside here, that take on sort of this triangular form. And so that means that a token at the tth dimension will only get sort of information from the tokens preceding it. So that's exactly what we want. And finally, I would like to rewrite it in one more way. And we're going to see why that's useful. So this is the third version, and it's also identical to the first and second. But let me talk through it. It uses softmax. So trill here is this matrix, lower triangular ones. Way begins as all 0. Okay, so